Greetings, everyone, from wherever you're joining us, and welcome to today's webinar, Creating Digital Confidence with Test Automation. My name is Alyssa, and I'm Director of Product Marketing here at Sauce Labs. But before we get started with the content today, which I think you're all really going to enjoy, I'd like to go over a few housekeeping notes so you know how to participate in today's event. So when you joined this webinar, your audio probably connected your computer speakers by default. If you'd prefer to join over the phone, you'll see in the control pane, you can select a phone call in the audio section, and the dial-in information will display there. If you have questions for our speaker, and our hope is that this content will be a great discussion, we ask that you please submit them via the questions pane in that same control panel. You can send in your questions at any time during the presentation. We'll answer as many as we can during the Q&A session at the end of today's event. And then finally, I'd like to remind everyone that today's presentation is being recorded, and you'll receive an email with links to view the recording and slides following the event today. And now, without any further ado, I'd like to introduce today's speaker for this session. Yoosuf Maktoum is the Senior Manager of Quality Engineering in the Business Technology Organization at Sysco Corporation. He's responsible for quality engineering, open source adoption, and performance engineering. He has a wealth of experience over 10 years in the IT industry, and his expertise is architecting quality engineering platforms, strategizing testing solutions, and leading multinational quality engineering organizations. Really excited for him to present today on this webinar. And so without any further ado, Yoosuf, why don't you go ahead and take it away?
Yeah. Thank you, Alyssa. Greetings, everyone. Thank you for joining with us today. Digital transformation or digital confidence. Today, we are live in a pandemic. So, even though we are live in a pandemic, and this pandemic impacted most of the economies and companies, global spending on digital transformation technologies and services will grow 10.4% in 2020 to 1.3 trillion. This shows how digital transformation is vital for companies. In this digital transformation, testing or quality engineering have a bigger role to play. Today, I'm going to share our experience in building digital confidence with test automation. I am Yoosuf Maktoum, Senior Manager, Quality Engineering at Sysco Corporation. As I lead QB practice and platform teams in different business units. If I introduce a little bit about Sysco. Sysco is a Fortune 100 company and a leader in the food service industry. We have more than 300 distribution centers and more than 55,000 employees across the globe. Sysco has a business in North America, Latin America, and Europe and Asia. With that, I'm going to go into my topic. So, situation as a tester or as a quality engineer. In the current digital transformation landscape, companies are aiming to create emotional and brand connection with the customers. But experiences can't be meaningful if they are not frictionless. To achieve that standards, it's important that companies don't forget the importance of quality engineering. Custom expectations are constantly rising and people want higher quality product, equipment and software than ever before. If you take today, let's take this GoToWebinar tool. So today you might join from mobile, laptops, Android, iPhone, iPad, or desktop computers, or I don't know if there are any other digital devices. And also if we take networks, we have 4G, 3G, 5G. So how we can ensure quality of this digital product? GoToWebinar. It's a very complex and complex. So we have solved this engineering problem with unique test automation architecture, framework, and platform at Cisco. When it comes to digital transformation, automation is the de facto mantra for successfully ensuring seamless quality. When I mean test automation, it's not traditional test automation. We can't achieve expected quality using traditional test automation. So you need to innovate around your test automation. That's what we have done. When we innovate, we we carefully innovated. We didn't reinvented the wheel. We always try to use existing open source and licensed tools. This is our challenge. If we take an enterprise, in an enterprise, the technology stack is very diverse. Most of the enterprises use both modern and legacy technologies. They might have a different types of architectures, such as microservices, service-oriented, or large monolithic. We call this as a hairball architecture. Also, they have a large number of integrated systems and different types of application. It can be a web, it can be a mainframe, it can be a desktop application, Oracle form, mobile, so different types of application. With all this complexity, an enterprise needs to give the best digital experience to both internal users and the huge diverse external customers. If we take our employees, we have more than 55,000 employees. So we have some system which used by employees. So still this is diverse. These employees are from North America, Latin America, Europe, and all over the world. So we need to provide that digital experience to them and also our external customers. We have more than 400,000 external customers, restaurants and businesses. So in this kind of environment, the quality engineering team has a tremendous responsibility to ensure that the application meets every customer expectations. So we can't imagine that. So most of the time, always QV teams are overwhelmed with all this DevOps and Agile and all this digital transformation. So they are the one get hit by all the release deadlines and all this most of the time. So this was our challenge. So we need to solve this problem, how we can give a best digital experience, how we can assure quality of that digital experience, and we need to meet the deadline, and also we need to stick with the budget, and also we need to protect our team members. We can't lose our employees. Employees are important. So what we have done is we built adaptable hybrid modularized test automation architecture and the quality engineering platform. This is in-house built platform and we have designed this architecture. So we use both licensed and open source tools to build this architecture and platform. Somehow we have resolved most of our quality engineering problem and we were able to deliver expected quality in our digital platforms. This is our journey. We started 2016 with the web browser automation on personal computers. At that year, we automated more than 1,000 test cases using this platform and framework. If you take our growth or our journey, we expand our capability every year. In 2018, we expand our automation capability to automate post devices, automate printer related test scenarios or test cases, mobile devices and iPad, and then some network related test cases or test scenarios. When it comes to printers, so we wanted to simulate actual digital experience with this printer. So what we have done is we didn't follow this traditional way of verifying printer contents. In traditional way, what we do is we log or we put our printer content into a log file, then we read that log file and we verify that. But we didn't do that. What we have done is we have built a small simulator, printer simulator, and we hosted that as a virtual printer in our network. So it has a network IP or it has a USB port. So we send that our printer signals or binaries to that virtual printer or IP, then we capture that signal and we convert that binaries to a string, then we verify. So in that way, we can simulate this network scenario also. Then again, we have some application that application behave based on the your network quality. So we need to simulate that also. What we have done is we have come up with a solution to mimic routers. In that way, we were able to simulate our real customer experience in our testing environment. Then if we take 2019, we moved to mainframe or test automation and also Oracle Forms. So with that, we achieved around 7,000 plus test cases. We have automated 7,000 plus test cases. Then 2020, today we have automated more than 10,000 test cases using this architecture framework and platform. In 2020, what we have done is we have automated some of the handheld devices. So these handheld devices are used across our distribution centers. These handheld devices types are very diverse. It's based on the weather, climate is differ. For example, it's cold. In cold weather, we have a separate type of handheld devices. If it's in Houston, so I'm in Houston, it's kind of a hot or sunny weather, we have different type of handheld device. So we have to automate this also. We achieve that also. So this is our journey. Within 4 years, we were able to automate more than 10,000 test cases. When it comes to ROI of test automation, we all know automation is for saving, cost saving, or save dollars or save time. But apart from what we have done is we have used test automation to improve our engineering capability, especially quality engineering capability, apart from functional test automation. And also we use this as a tool for retain our employees or our talent. Our employees are one of our assets. If you take passionate or motivated employees, they look for a challenging work. They want everyday challenging work. They are boring with this day-to-day, everyday, this automation and the manual testing. So what we have done is, so we innovated around our automation and our testing area. And what we have done is we have a platform and engineering team to do this innovation. It's around 8-member team, but we open sourced our platforms and our frameworks within our enterprise. So any of our quality engineers at Cisco can contribute to our platform. In that way, they are always motivated and they are happy with their work. So this is how we retain our talent. So this is one of the ROI of test automation. I will talk about engineering capability in my next slide. So cost saving, I'm not going to talk about that because there are lots of sessions and articles that cost saving we can talk. So already there. Engineering capability. So if you take an enterprise, again, enterprises have a different types of applications, and also they use, again, as I told earlier, they use both modern and legacy applications. So we can't use one specific tool to automate these tools, hardware or devices. So we want different types of tools. We need licensed tools and also we need an open source tool. What we have done is we have go for a hybrid tooling model. So we have built our own library using open source and licensed tools. We have our own API layer, which used by our test engineers or quality engineers to use their automation. Below that layer, all the UI automation, API automation, and all these performance tests are bundled in that below that. So we expose that layer to our quality engineers. They use that layer. So I will show that how we have architected that in later. Then second is reuse test automation to measure the performance. Again, I want to tell one story about this. Recently, around 1 year ago, we have modernized one of our biggest application. This is kind of a hierarchical architecture. This application integrated to multiple upstream and downstream applications. So to make sure quality of this product, you need to test end-to-end flow. When it comes to end-to-end flow, this has a web, mainframe, Oracle, and handheld devices, and some mobile devices. So we need to measure the end-to-end. Our business want to measure the end-to-end scenario, performance of end-to-end scenario. So that's a puzzle for us. So it's a biggest challenge we had. So we tried with already available tools, but we failed. We couldn't find a single tool which cover all these stacks for the performance testing. What we did is we used our test automation for performance testing, but that not the again traditional way. In traditional way, what we do, we automate. Automation is in the separate Git repo. We what we do is we automate. We build a jar file and we copy that to the JMeter library folder, and we use JMeter GUI to script the performance test. But we didn't do that. What we have done is we have integrated JMeter API to our automation suite. So it gives us a flexibility to measure the performance of this end-to-end flow. So we have all this tool to automate this end-to-end flow. Now we integrated JMeter to that library. Then we have a very sophisticated library to measure this end-to-end flow. I will show that also in next. Then test automation as a service, third one. Again, in enterprise. So these applications are tightly coupled or tightly integrated. So sometimes you might have some microservice applications also, but most of the applications are tightly coupled. So you can't test one application without other. You need some data. So when you simulate data, some of our application we can't inject data directly to database. That will crash entire test system, test environment. So we need to go through that UI flows. What we have done here is we have used test automation as a service for the integration testing. So let's say we have application A. Application A wanted the application B. We host the application B's automation script as a service. Then application A's automation script can use that B's automation script. That's how we enable the test automation as a service. Then hybrid scripting. We have some modern applications which have one single code base which support web browser application, web browser, and iOS and Android devices. So one code base, they support all this, and all within that also within mobile they have mobile devices and also tablets, iPad. So it's a so how we can reuse a single test automation code for all these three segments. What we have introduced is we have introduced hybrid test scripting. Then last one is omnichannel. So it's kind of a omnichannel means it's again end-to-end test scenario, but you will have different types of devices, different types of applications and technologies. So we have large number of hardware devices to be tested, and we have large number of different applications, different types of applications, mainframe, Oracle forms, all this. So we build the omni-channel capability on our platform and our architecture to build it, deliver that end-to-end testing capability. Again, this is how we build our capabilities. So we didn't jump and okay, we are going to do this right now. No, we didn't do that. We start again from 2016. We introduced modularization in our automation and platform. With that, we were able to reduce our test execution time. Then we introduced hybrid. Then we were able to use same automation code for mobile testing. Then we introduced 2019 reusability. Then we were able to reuse our test automation for the performance testing. Then we build our test automation as a service. Today we are there. Then we solve our test data problem. Our future is AI. Our expectation is to use AI to solve extreme user experiences. This is how we evolved our platform and our framework. There is a question always we ask, what to automate? Again, I am not a fan of 100% automation coverage. I don't believe that. Again, you can achieve that in API or service level automation, but UI level you can't. If you are going to achieve that, it will probably waste your time and money. So what we did is we always don't automate test cases within that sprint. So what we do is we check our customer feedback, how our customers use our features. Based on that, we automate. We come up with a customer scenarios and we automate. That's how we save our money. So with all this agile and DevOps, people say 100% automation coverage, and also you need to automate within the sprint of that particular feature. I don't believe that. I am not a fan of 100% automation coverage. I believe 80 to 85% automation coverage is good for a enterprise or company. And again, we wait customer feedback to start our automation. That's how we can give a good digital experience to our customer. So these are the some test automation architecture principle. First is design to be disable. When you design your framework, design to disable. For example, you have a 300 test cases in your regression suite, but you have to run specific test cases or specific modules. But these modules or test cases are across multiple devices and multiple applications. So you need to design to achieve that. And also you need to disable in runtime, not in coding. You can't do any code change to disable this your test cases. You should able to disable your test cases on runtime. Then use mature technologies. Then use commodity infrastructure. When it comes to commodity infrastructure, always try to use easily available and affordable to buy and cheap to maintain and replace infrastructure. Don't go to other things. Always try to get good commodity infrastructure. Then isolate faults. That's another important thing in automation. How we are going to categorize your automation failure. How we are going to rerun. So you can automate entire rerun process in test automation. These are some test automation architecture principles we follow. And then scalability needs. You need to design your automation architecture, your automation suite for your future business growth. So if you can't scale up your automation capabilities for future growth, that's you will be in a trouble in the future. So that's, if you say our journey, we have started 2016, but we at that time we saw our future 2020. So we need to head to here, but we started small. Today we have achieved more than 10,000 test cases, automated test cases, and we have different types of capabilities. So scalability is important. So when you design your automation suite, please think that. When it comes to quality engineering, so again, QV manager role, that's there, but quality engineering architect role now slowly becoming a trend. Before you think about your automation architecture, you need to think about your quality engineering architecture. How I am going to build a quality to deliver best customer experience. So when it comes to quality engineering architecture, you need to think about test types, test suites, application types, and UX. And also top of that, you need to you need to care about your application architecture and also system architecture. Again, enterprise architecture. So you need to align with your enterprise architecture team and also your system architectures and application architectures. Then test data. It's very important in an enterprise. Then automation tools and infrastructure. So if we take these green areas, we have built these platforms and tools in-house using open source and licensed tools. So then application under test. When you architect your quality, you need to think what's your application, what kind of application, what your user, all this you need to think when you architect your quality. Then automation as a service, your integration layer. What are the application I need to be integrated to test this? I need to integrate to test this application. For example, you might have a ERP system, HR system, transformation system, finance, identity management. So how I can integrate these kind of applications to my test automation. Finally, test environments. So very important. We have experience. So we had one automation suite. We had a good test automation architecture, all these things, but always its pass rate is around 55 to 60%. Then we did a deep assessment and we found out root cause is test environment. Test environment is not scaled scientifically to handle the test automation traffic. When you execute test automation, it sends huge number of traffic to your servers and your other integrated system. So in this particular scenario, our application under test works fine, but some of the integrated system couldn't serve our traffic. So again, test environment is important. So you need to focus on your test environment, sizing, and how this integrated, and what are the network topologies we have. In enterprises, we need to care about networks also, how these systems are connected, because we use different types of infrastructure. We use AWS, in-house servers, and also AS400 IBM data centers, and Azure. So how these networks are connected, that matters. Then test automation architecture. This is our adaptable, modularized, and hybrid one. So if we use same automation architecture and same automation code to automate this kind of application. Then we have a test data. Second layer is test data. Build, that means Maven or Gradle. Then CI/CD can be a Jenkins, or it can be a TFS or anything. Then execution lab. You need a execution platform to execute. Sometimes you might not be able to use your own. Sometimes you need to go for a licensed tools. So depending on your context, we need to do that. Then reporting. How you are going to report your automation results to your stakeholders. That's important. How you analyze the automation results. That's critical. So we build our own framework there. Then we have hybrid and modular scripting framework. So in that we have three layers: test layer, function repository layer, then object repository layer. So each of these layers have own boundaries and own rules. So I'll explain later. Then underneath, below that, we have our tools. As I mentioned, we have wrapped all these tools to a one service. we support Java, Node.js, and .NET at Cisco Corporation. We use this platform to automate using .NET, Java, and Node.js. Our automation scripting languages are Java, Node.js, and .NET. So this framework supports that. Then we have a utility layer that simulates our test environments, and also we have hybrid engine that identifies this test is for the iOS or Android or a desktop application, desktop devices. So we have nicely and it's a very decoupled. If you say it's a decoupled, anytime we can replace our execution lab with another tool. Anytime we can replace our CI/CD with another tool. Anytime we can modify function repository with minimum impact to the test layers and the object repositories. These are very decoupled and independent. Next, hybrid modularized test script design. If we take here, this is modularized. So for example, let's take one shopping cart application. You can have a large regression suite. Within that regression suite, you can have a separate regression suite for each and every module. For example, order suite for order module, user management for user suite, and payment module for payment suite. At any given time, you should able to run one of these modules independently. This is how we design our scripting. Then we have a test class, function class, and object class. We have set of rules. For example, test data. All the test data should be passed through test classes. You can't ignore test class when you pass test data. Test data should come through the test class. But when it comes to the tools, like for example, Selenium or Rest Assured or anything, so you can't go beyond page object layer. All the underlying tools should be used in page object and below. The function layer is for business logic. For example, let's say for a login scenario, for login we have typically we have three actions: enter username, password, and click login button. So we script all these individual action in this object class, and all these three composite methods, like all these three actions in a one method in function layer. Then all the test sets are in test layer. We need to follow this, and we have automated to govern this using Sona. So we have customized Sona rules to govern this. Then again, test automation as a service. We use test automation as a service for the test data requests and also performance test requests, performance testers. As I mentioned, we have used JMeter API, and we have integrated JMeter API to our application automation script or our platform. We don't use GUI. Then we have a automation as a service layer. This test data request and performance test requests communicate through this automation as a service. Then that automation as a service layer communicate with your test class, or it's depend on the function class. Sometimes we ignore test class and we directly call function class. Then we have a hybrid engine to identify is it a mobile, web, or any other devices or any other browsers. So hybrid engine works with function class and object class. It does not work with the test class. So test class sends the device type or your platform type to the hybrid function class. Function class sends that to the hybrid engine. Yeah. This is our overall automation as a service, and I'll show this is about my slide. I'll show small coding, how we use this, apply this as a coding onto our scripting, but I will not show that entire thing because of some copyrights issues. So I can't give that entire code. I can't show entire code, but I'll give small code. Yeah. In typical Java class, we have a main and test. What we do is we keep all our page objects and API calls, payloads in UI and main for a package, and we script all our test classes or test classes. We keep test classes in the test package. Then this is how we script our page objects. For example, for login, here I can't give that. I can show that our hybrid engine. We integrate our hybrid engine to here to identify the what locator we use, whether it's a mobile locator or it's a web locator. These are typical page objects. So if you see here, so all these tools, UI automation tools come up to here. And also we don't use that direct Selenium. So we have a API. So we use that API. Then we have function class. For example, this is our function class. So we call that login page in function class, and we do our actions here. Then we pass all the data, and data come from top and tools come from bottom. Then business logic all are in function layer. Then it's do all the actions. Then if you come to our test classes, this is our typical test class. Again, we have an init method, and all this data engine communicate on this layer. Data are populated in init test method, and when it comes to performance engine works with test layer to identify which test to be run and how it should be run, what's the traffic, what's the thread count, how much how many iteration I need to run, all these things handled in this layer. Then if we take our TestNG suits, we use TestNG, and we have a regression suit. Then we have payment, for example, module test suit for each module, for example, payment. Then login, each and every module have different suits. So, and then this is our util library, but we don't use util libraries like this. We have separate library to manage all these test data requirements. Yeah. Again, I'm going into my slide. Yes, I hope I have covered most of the thing. Now it's your time. Q&A.
Great. Thank you, Yoosuf, for that great presentation. I hope you can hear me a little bit better now. I seem to have had some audio issues in the beginning. You can hear me okay?
Yeah.
Great. Once again, thank you for that wonderful presentation. We have about 15 minutes now for Q&A. As a reminder for our audience, the Q&A panel is, or sorry, the questions panel is still available for you to ask your own questions directly there. We've had a couple come in right now, but let me start with some of these here. Yoosuf, does the test automation framework also work for containers or containerized products and microservices-based designs?
Yes, this do support both my container-based and microservices.
Great. Awesome. Good to know. As far as scripting, I know you talked a lot about different scripting abilities that you have within your organization. Someone asked in the questions panel if you've looked into any AI-driven tools for automation.
We haven't integrated any AI tools yet, but we are working on that. So probably in another couple of months, we are going to integrate that AI tools to our platform. And yeah.
Okay. Yeah, definitely a hot topic right now, AI,
yeah.
in terms of test automation, right?
Yeah.
Great. How about this question, which is one that I've heard a lot of as well from my side. How do you differentiate between the same test that's for functional testing and performance testing?
So that's why we have a engine. We pass a parameter and runtime to differentiate whether it's a performance test or functional test execution. Then we use TestNG grouping to identify whether that scenario comes under the performance test or functional test.
Okay. Lots of questions coming in. Thanks, everyone. Seems like you've started a great discussion here, Yoosuf. What about test execution? I have a question here that asks, do you have your tests running in the cloud?
Yeah, we at Sysco, we have some security protocols we need to adhere to. So we execute our execution lab. We have license. We have some third-party execution supports, and also we have built our own execution lab to cater the security protocols. So we have applications on the cloud, and also we have applications in the our execution lab in the cloud. So we use Jenkins as our execution platform, and we build small execution platform using Selenium Grid. And that Jenkins calls our Selenium Grid or our platform, and it's identify which nodes to be used to execute this test. Sometimes if this test needs to be executed on our third-party execution platform, it's automatically redirected to our third-party execution platform. If not, this execution needs to be executed on our own in-house build execution platform. We do that, and also we have our own on-premise execution lab at Houston corporate office to cater some of our own devices. All are integrated, and we were able to do omni-channel or end-to-end testing.
That's interesting, this like kind of hybrid environment that you've set up. That's a combination of a grid, a cloud grid, an internal environment. A follow-up question from me then is, how do you make the decision which tests run where? Is it because of the security reasons you mentioned in the beginning? Are there other factors that go into that?
Yeah, one is a security. Definitely, some of the application cannot be accessed outside our network. Some based on our customers. So again, if you do a performance test, so you can't do performance test on your own lab. So you need to simulate customer experience. So we use some external execution platform to simulate that. That's based on your context, customer experience. If you want to simulate the customer experience, that. Then again, execution time is matter. So if you want to speed up the execution, we need to execute parallelly. So what we do is sometimes we use all these three areas. We have our cloud application execution lab. Sometimes we use our third-party execution lab, and also our in-house data center device execution lab. We use all three parallel to reduce the execution time.
Got it. That makes sense. Yeah, and I like that call out to speed. Right, speed is key if we want a quality initiative to be successful, I imagine.
Yeah, speed and also your customer experience, especially for performance testing. For example, if you do performance testing on your network, there's no point because your network is fast. You have all these tunnels and all these things to communicate fast. So you need to, if you want to simulate digital customer experience, you need to go out of your, you need to simulate customer behavior. You need to use this all this 4G, 3G topology, and you need to simulate that.
Absolutely. That's actually a good segue into this next question, which is a bit more high level, but still really important for anyone on the call here who's trying to prove the value of automation at scale. Yoosuf, how did you convince the executive team at Cisco that the value of automation would be valuable enough or give that return to cover the resources that you spent on the elaborate design that you took us through?
Yeah, if you take automation, as I mentioned, automation, we have found there are 3 ROI. One is cost saving, that's one. Other one is revenue generation. So we try to increase revenue generation through our engineering capabilities, quality engineering capabilities, like identify different similar different user scenarios, and we have found some bugs in advance. So that's because of the automation. So one is cost saving, we reduce that repeated task. Another one is revenue generation through new innovation, and third one is to retain your resources, talented and motivated, passionate resources. They want technical work. They are QA engineers, they are testers, but still they want technical work. So that's a one tool, test automation. We tool that tool to retain our talents. So we work with our executives or our high management, these 3 areas to show ROI of test automation.
Absolutely. I especially like the second call out to revenue. I think that's such a key one that really helps you kind of speak the language of a leadership team. If you can tie testing back to real revenue drivers, then it becomes a pretty obvious choice that it becomes kind of mission critical for the business, I'd imagine. Yeah.
Yeah.
Great. And then talking about, data in general, being able to find those numbers and find those trends. There's a question here that just came in on how you're getting full test cycle reporting functions from your framework. How are you able to get all that data about the kind of the holistic test experience?
So we have built our own test automation reporting platform. This reporting platform supports both test automation and also performance engineering, performance testing using open source. We have all this data in that platform. Whenever our automation or performance test is executed, you can see the results real time. So you don't need to wait. We don't need to wait until that execution completed. You can see the results real time on our dashboard. And also in our reporting dashboard, we have 3 types of dashboards. One is test automation or performance test execution results, that mostly our engineers use that. Then we have a product related executive dashboard that used by our scrum masters, product owners, and directors. So they get all these quality engineering stats on the dashboard. Then we have a bigger level, VP, CTO level, the dashboard, entire company, how many test cases we have right now, manual tests, how many manual test cases we have right now, how many we have automated, how many we have pass rate, fail rate, all we have in another dashboard. So we have 3 dashboards. One is for high management, and other one is for middle management, and other one for engineers. So all 3 dashboards are built using open source, and this supports automation and performance test, and this is another platform. And also again, if you take an automation dashboard, it has a capability to analyze your test failure, whether it's failed or because of test environment, test data, or is it an actual bug. If it's actual bug, you can log a ticket in our defect management system through our dashboard. It's provide all the screenshot and all these logs, failure logs to the defect. I hope I give good answer to that question.
Yeah, I think it's great. I think it's great that you approach it from, you know, different levels of dashboards that have data that would be relevant to each person in the business, right? An executive might not want access to all the log reports and all the detailed information. They just want to see those high level numbers and how it's affecting kind of the pipeline and the flow of the business.
Yeah.
Yeah. Okay, we have time for one or two more questions. We're coming up here at the end of our hour. Someone asked for what are your tips on how to succeed when implementing automation on multiple fully mature and highly complex products?
Yeah, that's a good question. So your automation start with your regression sort. First, you need to assess your regression sort. What needs to be in my regression sort? Always try to keep your regression sort very minimal, and always try to reduce your regression sort growth. I would recommend annual regression sort growth recommended percentage is 10%. So we try to keep our annual regression sort growth under 10%. Then you have a good control of your regression suite. Then what we do is, what is our coverage? Automation coverage. Don't go for a 100% automation coverage. If it's a UI, holistic, it's not realistic. You will be wasting your time and effort and also money. So identify which suitable automation coverage. Then don't limit to one or two tools. Build, as I mentioned, build a kind of a framework which can provide you to use different types of tools. Especially in enterprise, you can't limit yourself to one tool. And also you can't limit yourself to open source tools. You might need to use both open source and licensed tools. So carefully design your framework. Don't build your framework based on your tool. Your automation should not driven by the tool. Then always think about your execution time. I had experience 2014 when I was working in a different company. They had a regression suite. It was automation. There was around 2,000 test cases. Automation execution time is 157 hours. It's a nightmare. So I was assigned to that project and I was told to reduce execution time. What I did is I bring down automation execution time to 7 hours. Then I introduce the parallel execution. Then I further reduce execution time to 1 hour. What I did is I didn't change any tools. I introduced a new automation framework. Same as this. This is the framework I introduced. Then finally, reporting. Test report automation reporting is very important. So all this failure analysis, rerun, you need to very careful, you need to be careful about that reporting, and also how you are going to show your report to your higher management, middle management. So reporting is very important. Yeah.
Awesome. Great. That's such a great overview, Yoosuf. Thank you so much. We are pretty much at time. So that's all the time we have today for this webinar. Thank you again, Yoosuf, for your time.
Yeah. Thank you everyone for joining. Thanks.
Great. Yeah, and I want to echo that. Thank you everyone for attending today. I just want to get two quick notes in before we close here. So when you exit the webinar, you'll see a survey on the presentation, and we'd really appreciate it if you just took a couple seconds to provide your feedback on that survey so we can continually improve. You'll also receive a follow-up email shortly with links to view the recording and slides from today's webinar. On behalf of Sauce Labs and our presenter, thank you for joining us and enjoy the rest of your day. Thanks again.